Look at your own hand. It feels completely solid. But that solidity is an illusion, hiding a highly complex collection of chemical elements. Every physical object on Earth, including your own body, is constructed from a menu of just 92 naturally occurring ingredients. These are the elements on the periodic table, things like carbon, oxygen, and iron. But when we examine the universe at large, we run into a major discrepancy. The wider cosmos doesn't look like this at all. It consists almost entirely of a single basic element, hydrogen. Hydrogen is the absolute simplest atom in existence, just one proton and one electron. Yet human biology requires heavy, complex structures to function. You can't build a beating heart or a functioning brain out of raw hydrogen gas. This creates a physical problem. A rule of causation in physics is that you cannot manufacture new elements simply by remolding existing ones. You never finish with more material than you started with. So if the universe began as a vast cloud of simple hydrogen, where did those other 91 heavy ingredients come from? To understand our own anatomy, we have to reverse engineer the universe itself. We have to trace our elements back to a cosmic forge capable of building them. The primary mechanism driving the universe is gravity. Over immense spans of time, gravity pulls vast, empty clouds of primordial hydrogen together, crushing them inward and igniting them into a star. As gravity squeezes the hydrogen, internal temperature skyrockets. Intense pressure forces atoms to violently smash together, fusing into helium. This triggers an ongoing chain reaction. 3 heliums make carbon, 4 make oxygen, 5 make neon. The core grows progressively denser. In smaller stars, like our Sun, this fusion process eventually hits a limit. The star lacks the gravitational weight to keep crushing the atoms together past carbon or oxygen, leaving behind a dense, stable core. But massive stars have much more gravitational weight. They squeeze even harder, pushing the fusion chain reaction further down the periodic table to build elements like silicon, sulfur, and calcium, until the center of the star reaches iron. These celestial bodies function as active, high-pressure factories, systematically manufacturing the complex ingredients required for physical matter. But iron is the ultimate cosmic dead end. Throughout a star's life, the outward explosive force of nuclear fusion perfectly balances the crushing inward weight of gravity. Iron, however, yields no nuclear energy. When the core turns to iron, that outward push suddenly vanishes, leaving gravity entirely unopposed. Without fusion fighting back, the entire mass of the star collapses inward instantly. The core is squeezed to an impossible density, the equivalent of packing 100,000 aircraft carriers into a single pint-sized container. This extreme compression causes a violent rebound. The gravitational energy from the collapse violently blows the outer portions of the star apart in a supernova. This explosion acts as the delivery mechanism, blasting all of those newly forged heavy elements out across the vacuum of the galaxy at high velocities. The violent death of a massive star is the only natural mechanism powerful enough to forge and scatter the heavy ingredients needed to build life. That scattered stellar debris drifts through space, cooling and spreading over billions of years. To understand the true physical nature of this scattered heavy matter, we look to Albert Einstein. Through his reevaluation of physics, Einstein showed that what we experience as mass, the actual heaviness and physical resistance of these elements, is simply a form of potential energy. That energy is permanently locked into the particles by the immense gravitational and electrical forces that squeezed them during the star's collapse. They are wound up tightly against these forces, much like a coiled spring. The solid matter we interact with daily is actually frozen energy, forged and bound together in a cosmic conflict between gravity and nuclear power. Over deep time, that drifting, heavy shrapnel from dead stars began to fall together under the pull of gravity, accumulating to form planets, oceans, and atmospheres. Those specific elements built our world, and eventually, us. The exact same iron atoms forged in the collapsing core of a supernova are right now binding to oxygen and pumping through your bloodstream. The 92 ingredients that make up our physical reality exist solely because, billions of years ago, gravity overwhelmed the nuclear energy of ancient stars. We are not separate from the cosmos. We are constructed from it. When you look at the stars, you look directly at your own origins.